Hi, and welcome to the second session on Excel for Finance. In this session, we will discuss about computation of rate of return, growth rate, etc. Before we get into the computation part, let me show you a couple of real-life situations that we often encounter. So, for example, I bought a piece of land for 20 lakhs 8 years ago. Today, if the market value of the land is rupees 35 lakhs, I would like to know what is the rate of return on this. Similarly, a zero coupon bond is available for rupees 6,200 today. A zero coupon bond is one where the bond doesn't pay any interest during the life of its life. If this bond has 6 years to maturity, and at the end of 6 years, it gives me rupees 10,000, which means I can pay 6,200 today to buy the bond and receive rupees 10,000 at the end of 6 years. I would like to know what is the yield on this bond. Another situation is, say 10 years ago, if I paid rupees 45 for traveling from Bangalore to Tumkur, and today, if the same costs me rupees 95, I'm interested in knowing what is the growth rate in the fare. So in all these situations, we may call it by different names like rate of return, yield, growth rate, or a more popular measure, compounded annual growth rate, CAGR. In all these cases, we are referring to the value of R in the following equation. You remember this equation we saw in the first session, the equation for future value, which is equal to present value into 1 plus R to the power of n. In all the examples I gave you, we had the future value, we knew the present value, we were knowing the number of years, but R was not known. So how do we get the value of R? It is simple. It's nth root of future value divided by present value minus 1. Now let us go to Excel and see how we can use Excel for computation of this rate of return. Okay, so here I have a Excel sheet where I've taken the second example of a zero coupon bond. The price of a zero coupon bond, which is present value, is rupees 6,200. Since I'm paying that price today, I have shown it as a negative cash flow, which is minus 6,200. The maturity value of the bond, or what I'm getting at the end of 6 years, is a future value, which is 10,000. And the number of years to maturity value of n is 6. There's a function in Excel which automatically gives you the rate of return, and the function is called rate function. The syntax of rate function is rate, bracket open, period, 2 commas, present value, comma, future value, bracket close. Now let me show you how to use this function. Let us start typing. Is equal to rate. The moment I open the bracket, Excel prompts me the first number I have to key in is NPER, or number of years. So I just click on this. Then I have a comma, one more comma, because there is one PMT, which we will skip for the time being. Then there is present value, which is minus 6,200. And it asks me for the future value, which is 10,000. I close the bracket plus press enter. So I get the rate of return, which is 8.29% in this case. If we want, we can increase or decrease the number of decimals in this. So this is how we can calculate rate of return, growth rate, or compounded annual growth rate using Excel. Okay, now, so as we saw, the Excel function for calculation of this is rate, period, 2 commas, present value, and future value. But I want to tell you one thing, that in all these cases, we have assumed that there are no cash flows during the period in between. That is, the bond we used was a zero coupon bond, so it doesn't pay any interest in between. Or the piece of land which I bought 6 years ago, during the last 6 years, I have neither spent any amount on that land and nor received any income in that. So there are only 2 cash flows, one present value, one future value, no in-between cash flows. If there are cash flows in between, how do we calculate the rate of return? It's slightly different. We shall see it in a session in future. So thank you for watching. I hope you enjoyed this video. Thank you very much.